And the great conclusion of this is that the universe is not only expanding, it's expanding in an accelerating way. So it's like it's only getting faster and faster, and there's a force that actually is pushing the universe apart. Now this force, which cosmologists call dark energy, is exactly this parameter that Einstein introduced, the so-called biggest blunder, the extra physical phenomena that he conjectured to hold back the universe. In fact, it's there, but it's working just the opposite way that Einstein figured. It's not slowing down the expansion, it's actually adding to the expansion. And in fact, this has dramatic consequences in the sense that in the end, the universe will be expanding so fast that most of the galaxies that we see now will actually be far, far away, and we will actually in some sense look in a dark void. Now, this was, of course, an equation and a result that got lots of attention. Last year's Nobel Prize was, in fact, awarded to this phenomenon. And I guess you also know the consequence of this, which is that physicists are in this wonderful position that they know exactly what they don't know. So 96%, according to these computations, of the universe is either in the form of the dark matter or dark energy, which is just a fancy way of saying there's some physical phenomena that we don't understand, but we see its presence. And only 4% of the universe consists of the particles that we describe in our textbooks and that we teach in our lectures about. I often ask people in other fields, what's your percentage of dark matter? How much do you know that you don't know? It would be very interesting to ask this question in economics. Of course, there's also the so-called unknown unknowns, which are things that you don't even know that you don't know them. And that, for instance, this dark energy was in that category 10 years ago. Because basically every cosmologist at that time would have claimed that this 4% was everything. So only now we come in this kind of very modest position that we only have to find this another 96%. So I always feel that cosmologists and physicists are a little bit like these old people making map makers who charted some part of the territory because there was a large part which was unknown. And of course they're very difficult to leave that empty. So they sketched all these kind of sea monsters there to be there, right? So these are kind of dark energy and dark matter are kind of the sea monsters, I think, of present-day physics. And perhaps the physicists are in this little boat trying to figure out whether these monsters are really there. But we're still mapping it out. Now, what could be the possible explanation of these effects? These big question marks that are, so to say, in the sky.